Welcome to HurricaneCenterLive.com. I'm Alex Garcia, Director of the National Tropical Weather Conference and Executive Producer of these programs. These programs are made possible by USAA, the South Padre Island Convention and Tourist Bureau, and Plylock's Hurricane Clips. These programs are also a team effort with Bill Reed, the former Director of the National Hurricane Center, and Tim Smith, Chief Meteorologist of KRGV-TV. And now, here's Tim Smith.
Thank you, Alex, and good morning, everybody. Welcome to NTWC Live for this Wednesday morning. We are glad to have you along. This is a big day in the hurricane world, one of those days we wait for every year, like a couple of other days earlier in the season. In just a second, we'll get to Dr. Phil, the real Dr. Phil. We want to thank, as you mentioned, Alex, all of our sponsors who make this event possible. USAA still with us, and we appreciate them from the beginning, doing all that they do. Plylock's Hurricane Clips, they came in handy this past week. I know a lot of people who used them down here in South Texas when Hurricane Hannah came through the area, and I have a hunch that they may have been used extensively on the East Coast this week as well with Isaias, which Bill's going to talk more about in a second. And the South Padre Island Convention and Visitors Bureau, they are open for business. I was there yesterday to watch the SpaceX hop. Open for business, doing well. It's a great place to watch the future of rockets as they launch them from deep South Texas, from Boca Chica Beach, which is 5 miles south of South Padre. And South Padre, the nearest place where you can watch those launches. So it's a pretty cool place to be. A lot to do today. So let's get over to Bill to talk about what's happening in the tropics right now. And Bill, what did you say about showing the 384-hour GFS?
I said I don't show pornography when I do these shows. It's forbidden. We'll worry about that later. Right now, the tropics are quite quiet. There's a couple of suspect areas with low probabilities of development and doesn't really look that promising. Yesterday, we had a couple of landfalls. A typhoon made landfall south of Shanghai and China, and those remnants will be bringing rain to the Korean Peninsula today and tomorrow. And of course, we had Isaias make landfall and run up the East Coast. That was our second hurricane landfall already in 2020. We've had 5 landfalls, counting the tropical storms, and Arthur barely missed landfall when it came by the Carolinas and had an impact there. A couple things I wanted to show. There we go. From Isaias. These are snapshots I took at the same time. The one on the left is from the Wilmington, North Carolina radar, and the Morehead City one on the right. At landfall, when we got in, the radar got in the eye of Isaias after landfall, and the winds, it looks like the winds are really dropping off there, and I actually saw some people commenting on that. Well, the winds are rotating around the center of the storm, so the radar beam is normal to the wind field at all directions. Thus, you get a reduction in the inbounds and outbounds. So it's important to look at adjacent radars, even though it's higher up, and you can still see the 100-knot core on the east side and the 70-knot or so core on the west side in there. I also pulled up the wind profile since the radar the center line was just past the O and Oak Island there. So the center line of the eye passed just east of the radar site. So they never got into the calm wind, but you can see the swing around from the strong easterly component winds to a light northerly wind as the eye went past there on that. And the last thing I wanted to show is sometimes we talk about it a lot. It's sometimes neat to get a great example of it. A week or so before Isaias, actually right around the time of Hannah, I was actually looking for the water temperatures in the Gulf, but the temperature anomalies where the oranges are significantly above normal. The light colors here are near normal in the Northwest Bahamas, but most of the area that Hannah went through before it formed were above normal. And then afterwards, we have this great swath of cooler than normal temperatures caused by the wind effect of Hannah has started to shrink here along the north coast of Texas. So I'll stop talking here and turn it over to our expert on seasonal forecasting, Dr. Phil Klotzbach.
Phil, go ahead and unmute yourself, please.
You would think by now I would know this. I'm using it once or twice, but apparently I needed more forecast day donuts. But anyway, when you're going out and about, I heartily recommend that you get your National Tropical Weather Conference face mask, because it's always important to wear a face mask when you're outside in public at this point. So why not do it in style? Let's get ahead and start talking about the August update of the seasonal hurricane forecast. Whenever I do seasonal hurricane forecasts, I always want to start by obviously acknowledging Dr. Bill Gray, who hopefully a lot of you got the chance to meet. Dr. Bill Gray is the founder of the seasonal hurricane forecast at Colorado State. He made fundamental contributions to tropical cyclone genesis, structure, intensity change, just an all-around giant in the field of tropical meteorology. And we've been doing seasonal forecasts at Colorado State for this is our 37th year of doing seasonal forecasts. One thing that Dr. Gray always did on seasonal forecast day is bring in donuts for seasonal forecast day. So here's the forecast day donut for the August forecast. And as you can see, if you squint, you can see we've increased our forecast and call for an extremely active 2020 hurricane season. So here are the forecast numbers. These numbers are about twice the average hurricane season. We're calling for 24 named storms. Now that seems like a tremendous number, but keep in mind we've already had 9. It's not that unusual to still get 15 storms after this. Remember, a lot of the storms up until the last 2, Hannah and Isaias, which are obviously both hurricanes, the first 7 storms in general were pretty weak and short-lived. 12 hurricanes, including the 2 that have already formed, and 5 major Category 3, 4, 5 hurricanes. Our forecast is for accumulated cyclone energy of 200. To put that in perspective, 2005 had about 250 ACE. So we're forecasting a very, very active overall hurricane season, about twice what you get in a normal hurricane season. So far, it's been very active. Here's the numbers through yesterday, or through Isaias, which dissipated overnight, or now post-tropical. We've had 9 storms so far. The average is 2 hurricanes. And if you can see, a lot of these parameters are running about 200 to 300% of normal. Obviously, normal to date is generally fairly low. The normal climatological season really does ramp up as we move later into August. Dr. Gray used to ring a bell every year on August 20th, signaling the active part of the Atlantic hurricane season. About 85% of your major hurricanes actually occur after August 20th. So the season still has a long way to go. We're 2 months into the season, but we still have about 95% of the accumulated cyclone energy historically left to generate. Here's the tracks of the 2020 storm so far. We've had 2 landfalling hurricanes. As Bill mentioned earlier, we had Hannah in Texas, Isaias into North Carolina. The 5 landfalling named storms that we've had is actually a record this early in the season. The prior record was 1916. However, in 1916, of those first 5 storms, we had a Category 2 hurricane, a Category 3 hurricane, and a Category 4 hurricane. So in terms of the impacts of the storms, certainly not as impactful as the ones that we had in 1916. So now just kind of dialing into kind of climatologically where we expect storms to form during August. Climatologically, storms in August tend to form in the eastern and central tropical Atlantic is one of the hot spots where they tend to form. What's known as kind of the main development region. So these systems moving off Africa, they tend to form and then ramp up and intensify. Here, they're color-coded, so greens indicate where they formed. The strongest they ever got was a tropical storm. Blues, the max intensity was a Cat 1 or 2. And the reds are Category 3s and 5s, which are the major hurricanes, winds of 111 miles per hour or greater. And while they only make up about a quarter of the storms that form in an average year, when you take those storms and you normalize them by population, inflation, and wealth, they do about 80 to 85% of the normalized hurricane damage. Here's a figure showing where the storms in August historically have made landfall. This is using up to 2019. We have Hurricane Camille in 1969, which was a Category 5. You can see making landfall near Pass Christian, Mississippi. And then the dot in South Florida, which I'm sure a lot of you are familiar with, Hurricane Andrew in 1992. This is through 2019, and not to be outdone, 2020, we've already had an August hurricane landfall with Isaias making landfall a couple of days ago. So why are we forecasting a very, very active season? Well, if you're checking Twitter, I have a few tweets queued up that will kind of highlight a lot of what I'm going to present here. In the tropical Pacific Ocean, we have what's known as cool neutral conditions. So we're not officially up to the La Nina threshold, but the water temperatures are somewhat cooler than normal. So they're not quite to the La Nina threshold, which is 0.5 degree Celsius colder than normal. They've flirted with that. They've gone below it for a little bit, but those need to persist for several weeks for NOAA to officially declare a La Nina event. And you can see lots of oranges and yellows in the tropical Atlantic, meaning warmer than normal water temperatures. And warmer than normal water typically does not bode well for the Atlantic hurricane season. That means a lot more fuel for storms, also associated with lower pressure and weaker shear. And I'll talk about some of those factors as we dial in. First, just to look a little bit at El Nino, here's a figure showing water temperatures in the tropical Pacific. If you look in the central and eastern tropical Pacific, that black rectangle highlights what's known as a Nino 3.4 region, which is the region that NOAA uses to assess basically whether an El Nino is present or not. Again, when water temperatures there are 0.5 degrees Celsius or more colder than normal for a specific amount of time, then NOAA will declare a La Nina event. Also, you have to have other atmospheric conditions be similar to what you expect in a La Nina event. Last year with El Nino, we actually had water temperatures that basically met the definition, but the atmosphere never quite coupled, and NOAA didn't officially declare an El Nino event with the event last winter. This is the most recent forecast. There'll be another update forecast, I believe, actually coming out tomorrow. The official forecast from NOAA gives a very, very low chance of El Nino. Frankly, whether the water temperatures officially meet the La Nina threshold or it's on the cool side of neutral, basically either of those can lead to a very active season when the Atlantic is very conducive, and I'll try to convince you that the Atlantic is extremely conducive for hurricanes in 2020. Here's a figure showing sea surface temperature anomalies or differences from average in the tropical Atlantic, and you can see lots of yellows and oranges indicating warmer than normal waters. And these water temperatures are running about 1 degree Celsius-ish warmer than normal, which doesn't really seem like a lot, but that's a lot more fuel for the storms. You normally don't get big temperature changes in the tropics. Also, when you have the warmer water, you tend to have lower pressure, weaker winds that lead to less shear. And certainly we've had those in the month of July. And one thing with the tropics is there's a lot of persistence. So if the shears are low, the pressures are low in July, typically they also remain low for the peak of the hurricane season, which is why historically the August forecast has quite good levels of skill. So here's a figure showing basically in the past what is correlated during the month of August. So basically darker colors here indicate stronger correlations with accumulated cyclone energy, which is an integrated metric that accounts for intensity and duration of storms. So if you look at this figure, you can see lots of warm colors, dark colors in the deep tropics, indicating that's where historically August, when you have warm water temperatures there in August, that's historically what is correlated with very active Atlantic hurricane season. So if you step back and look at this figure, and then you look at this figure, you can see it's a pretty good match, which is one of the reasons, obviously, when we monitor hurricane conditions, we talk about water temperatures in the tropical Atlantic. It makes sense since that's where a lot of your strong hurricanes develop and intensify. This is a plot showing basically how 2020 is tracking compared with historical hurricane seasons that reach specific thresholds. So blue line is hyperactive hurricane seasons, which NOAA defines to have a specific ACE threshold. And you can see the brown line, the thicker brown line, which is 2020, is tracking above what hyperactive hurricane seasons have in past years. So certainly the sea surface temperatures are very warm. To put this in another perspective, what this is showing is hurricane seasons, some of the really, really big heavy hitters. So 1995, 2004, 2005, 2010, and 2017. And you can see 2020 is basically tracking about as warm as 2017 to date, a little bit below 2005 and 2010. So right now it's in 4th place on record for sea surface temperatures. This is from the NOAA High Resolution Sea Surface Temperature data set, which goes back to 1982. Vertical wind shear is also very, very low, and that's a critical component for hurricanes in the Atlantic. And shear in the Atlantic is typically fairly marginal for hurricanes, which is why you have big variability year on year. You can have years like 2013 with only 2 hurricanes, and years like 2005 with 15 hurricanes. So here, blue colors indicate lighter vertical wind shear because historically your wind shear in the Atlantic is out of the west, so easterly shear reduces your normal shear in the Atlantic. And so you can see lots of blues indicating reduced levels of vertical wind shear. So now here's a similar plot that I showed for sea surface temperatures, but for shear, and you can see again, the shear is lower than what you get historically, even in hyperactive seasons. Right now, the shear is basically running in line with what we had in 2005 and 2010, which both had very, very low levels of shear. You can see in 2010, the shear actually even went slightly easterly when averaged over the central Atlantic and Caribbean. As you can see, the shear was actually negative, which means the shear was out of the east, where historically shear is out of the west. And that's one of the reasons why the Atlantic hurricane season really dies down in late October, is because the shear gets way too strong. The sea surface temperatures stay elevated, but the shear gets too strong and you don't get storms forming. Typically, you don't get much storm formations after late October. Sea level pressures during July were at their lowest levels on record, and this is from a reanalysis data set that goes back to 1948. Typically with reanalysis prior to the satellite era, it gets a little bit dodgy for upper level stuff, but sea level pressure, probably reasonably accurate going back to 1948. The lowest pressures on record for the month of July, lower pressures to mean a more unstable atmosphere. It also tends to feed back to weaker trade winds persisting during the peak of the hurricane season, which means more warming of the tropical Atlantic. Also, we've had a very, very persistent circulation in the tropics, whereby the greens here indicate upward motion, the oranges indicate downward motion. We've had a lot of upward motion over Africa, downward motion over the tropical Pacific. That's a classic signal for an active hurricane season. We've also had generally elevated rainfall totals in the Sahel region of West Africa. That tends to mean that the waves that are coming off Africa, the thunderstorm complexes are generally stronger, more intense, and typically these more robust easterly waves are more likely to develop. That's kind of a canonical Bill Gray predictor that's been used that we've looked at off and on for probably about 30 years now. So we do have, we don't just look at features, we actually have some modeling that goes into this as well. One of the primary things that we use is a statistical model, and it uses a total of 3 predictors. And these 3 predictors worked well at explaining historical hurricane seasons going back to the early 1980s, since that's when that high resolution sea surface temperature data set begins. Predictor 1 is assessing basically winds in the Caribbean. When the winds in the Caribbean are weaker than normal, so the trade winds are weaker at low levels, that tends to mean low pressure in the Atlantic, high pressure in the Pacific, indicative of probably trends towards La Nina conditions. Also tends to be weaker shear in the Atlantic. Sea surface temperatures in the subtropical Atlantic, when those are warmer than normal, that tends to be associated with a weaker Azores high, which means weaker winds blowing into the tropics, feeding back into warmer water. When you have upper level easterlies over Africa, that tends to be associated with stronger easterly waves, also reduced upper level winds, reduced vertical wind shear in the Atlantic basin. So these 3 predictors in combination have done very well at forecasting, or basically hindcasting, so basically using these predictors to predict historical hurricane seasons back to 1982. This is forecasting after the 31st of July, accumulated cyclone energy, or ACE. You can see in general, the model does reasonably well. It's certainly not perfect. There are some years where it over forecasts or under forecasts, but in general, the model does a reasonably good job of forecasting historical hurricane seasons back to 1982. Here's what the statistical model says. So you can see the statistical model and what our final forecast is are very close. We're forecasting a well above average, obviously, overall hurricane season, right in line with our statistical model. We also use analogs, which involves going back into the past and looking for years in the past that look similar to what we currently see and what we expect to see for the peak of the season. And you can see that all 6 of these years were very active hurricane seasons. But you can see that even though the accumulated cyclone energies are fairly similar, that they can do this in different ways. So you have a year like 2003 that only had 3 major hurricanes, but those major hurricanes lasted almost 17 days. Whereas in 2010, we had 5 major hurricanes. They only lasted 11 days. And when it comes to ACE, those 2 years were fairly similar. And that's one of the things, is that it's hard to know exactly how the year is going to shake out in terms of if you're going to get maybe somewhat fewer storms, but lasting longer, or more shorter-lived storms. Say like we saw in 2005, we have obviously a tremendous number of storms that year, but if you say look at the number of major hurricane days, 2017 actually had more than we did in 2005. But you can see that the average of our 6 analogs is pretty close to what we're forecasting. One thing I want to point out is that these analogs are based on kind of overall what we see for the large scale in the tropics. It's not to say that we're necessarily, because we're predicting 2005 as an analog, that we're going to see the storms that we saw in 2005. Obviously, 2005 and 2010 were both very active seasons. 2005, obviously, we got hit by quite a few nasty hurricanes, whereas 2010 was a great year in that we had 12 hurricanes, but none of them actually hit the U.S. So we were very, very lucky that year. Obviously, we already know we're not as lucky as we were in 2010 since we've had 2 hurricanes and they both have already hit the U.S. Here's what you look at when you look at the 6 years that we selected as analogs and look and see kind of what the overall conditions look like. The tropical Atlantic was warm. Overall, we had weak La Nina conditions if you average the 6 years. Obviously, 2010 was a much more robust La Nina event than what we expect this year. However, other factors, other things that we look at, such as water temperatures and shear, are tracking fairly similar to what we saw in 2010. And as you know, in meteorology, there's never any perfect analog for the current season. There's obviously going to be some things that are similar and some things that are different. We also do probabilities of exceedance, which is trying to basically calculate the uncertainty associated with the forecast. And we do that by basically you looking at the historical errors of the forecast and then basically estimating basically confidence intervals based off of that. So you can see our confidence intervals anywhere between about 150 ACE, which is an above average season, but not obviously record setting, up to 250 ACE, which is about as much ACE as we've ever observed. So that's our current confidence interval. And we have similar uncertainty ranges for all of our different predictors. And so if you look at these ranges, these are fairly similar ranges to what you would see in a NOAA forecast. So 3 named storms, plus or minus 2 hurricanes. So again, a very, very active season. But you can see, obviously, there is uncertainty, accumulated cyclone energy anywhere between about 150 and 250. Likewise, major hurricanes between 3 and 7. So we give you the numbers that are our best estimate, but obviously, as all of you know, there is uncertainty associated with these forecasts. But I would say we have very high confidence that the season is going to be well above average. Exactly how much above average the season is remains to be seen. We also provide probabilities of landfall, and these are obviously updated for post-4 August because obviously we've already had 2 hurricanes hit the U.S. So historically, the probabilities on the right-hand side, these are the full season averages, and if you look at it just after the 1st of August, the probabilities don't change very much since you don't get a lot of landfalls. Historically, in June and July, especially for major hurricanes, this year the probabilities are elevated, and the reason that they are is simply because we're predicting a well above average hurricane season. You can't say months in advance when or where the storms are going to strike, but in general, more active seasons do have more landfalling hurricanes. One of the real challenges with forecasting the steering of the storms is because the tropics have a lot of persistence. So if the shear is low in August, it's going to probably be low in September and October. But if you're looking at mid-latitude steering flow, which dictates where the storms are going to make landfall, that's governed a lot more by day-to-day weather conditions. So even if you can forecast the 3-month average steering flow is going to be such, doesn't necessarily guarantee that there isn't going to be a day in there that the storm's there where the steering flow is going to be different, which is why most seasonal forecasts may predict overall basin-wide activity, but they're not necessarily going to say a ton about exactly where the storms are going to make landfall. If you're interested in more information on seasonal forecasts, I invite you to check out seasonalhurricanepredictions.org. We have over 25 different groups submitting seasonal forecasts. I saw several groups actually updated their numbers today, so even the plot that I'm going to show you next is already outdated. I'll be updating the CSU forecast numbers here in the next couple of hours. So basically, we have over 25 different groups submitting seasonal forecasts. Certainly, we're not the only show in town. NOAA will be putting out their forecast tomorrow at 11 a.m. Eastern time, so definitely check out their outlook. There's a whole pile of other groups doing seasonal forecasts. These are all done by credentialed meteorologists and climate scientists. They span government agencies, private sector, weather companies, as well as universities. We actually have more universities contributing from landlocked states like Colorado than we do from universities in states that actually border an ocean. The website does display the seasonal forecasts. They're color-coded, so purples are from private weather companies, pinks are from government agencies, and the cyan or blue colors are from universities. The orange dot is the average of all of the forecasts, so that orange dot might be coming up a bit. Some of the forecasts that have been coming out more recently are forecasting more hurricanes. The red dot is what we have observed to date. We've had 2 hurricanes so far. So with that basically sums up what I want to talk about today. And I think certainly whenever any of us do seasonal hurricane forecasts or forecasts for anything, certainly we always agree with the admonition from Arago, who was the head of the Paris Observatory during the mid-19th century, who stated that never, no matter what may be the progress of science, will honest scientific men, keep in mind this was the mid-19th century, we can certainly now say honest scientific men or women who have regard for their reputations venture to predict the weather. So with that, I'd like to thank you very much for your attention. Here's a few ways to contact me, and I'll try to answer any questions.
Terrific info, Phil. Thank you. And I'm glad we've already had ours. We can step down, right? I wish that was true.
Yes, I should mention Texas gets hit by more hurricanes in August than in September. So August has really historically been the biggest month for Texas for landfalls.
You're not putting me at ease exactly, but thank you, Phil. we appreciate great information. Thank you, and everybody I hope has gotten a lot out of that. You can stop screen sharing now so we can see as questions start to come in. I'll start with this. How far back do you look for analog years? I noticed that 4 of the 6 were in the last 17, 18 years. How far back do you look for those? Yeah,
we go back to about 1950, typically more analog years from the more recent period, just because in general with the long-term climate warming, the overall water temperatures are warmer. So you can still have inactive seasons with warm water temperatures, but usually I would say, I usually will look back to about 1950, but generally the more recent data is going to also be more reliable. And we have enough active and inactive seasons since 1980 or so that we can use that more. But if we see years prior to 1980 that look like really good matches, 1966 was a year we liked just because it was a very active early season. 1966 is kind of interesting because it was very active early and then just kind of flamed out after that. It ended up about average overall, a little bit above, but it started off very, very active and then kind of quieted down.
Was there anything, if I saw right, every indicator points toward an active season? Was there any indicator that says no? Is there anything that would make you even go higher in the numbers, or is this it? Do you think?
It's hard. You don't normally, 12 hurricanes is about, you get 15 like 2005, but in general, 12 is about the max. There wasn't much that I could see that was a quieter season. One of the things that was kind of until late July was we hadn't seen any storm formations in the deep tropics. Through about mid-July. Normally, deep tropical formations, it's not a necessary condition. You don't necessarily have to have it, but if you do get deep tropical storm formations in July, it's typically a harbinger of a very active season. And we've had 2 of those since. We had Gonzalo and Isaias form in the deep tropics. So even that has been met. So no, I would say really, it looks like the next 10 days or so could be fairly quiet, but then it looks like things are really going to ramp up as we get towards the time where Bill Gray rings the bell around August 20th. I did mention it here, but we do actually do sub-seasonal 2-week forecasts. We'll be putting out our first 2-week forecast later today.
Terrific. Okay, Bill, jump in here because I know you've got plenty of questions. Bill Reed from Houston. Go ahead, Bill.
Oh, yeah, you hit a few of them right there. One other aspect, a lot of chatter of people I tend to follow every now and then in the science world talk more about ocean heat content than sea surface temperature. Have you looked at that factor at all for the seasonal forecast aspect?
Yeah, the problem with it is that it doesn't necessarily go back far enough. I like to have about 40 years of data to build a statistical model. But if you look at upper ocean heat content, it's definitely amped as well as sea surface temperatures. So if you want to look at upper ocean heat content, it's running very, very high this year. So certainly either of those. I've seen a paper or two arguing that upper ocean heat content works better from works just as well, if not better, from a seasonal forecast perspective. But again, the amount of long-term upper ocean heat content data that's reliable isn't. I think sea surface temperature data, you can go back farther with more accuracy than you can for upper ocean heat content.
Okay, yeah, they're kind of related to that. One of the things that caught my eye was an earlier picture that someone showed the corresponding ocean heat content in 2005. It was some period in July, I forgot when. And then what it was at that point this year was much higher in the Northwest Caribbean than what we had seen in 2005. Have you seen that?
Yeah. It's definitely, it's very, very high. Again, especially in the Caribbean and in the Gulf, the waters are always plenty warm to support any nasty hurricane that you want. It's other factors that really dictate whether you get storms in those regions. It's usually we actually look at sea surface temperatures a little farther to the east because that's where the thermodynamics tend to be more marginal. Because kind of canonically in the Eastern Atlantic, your shear is fairly low, but your sea surface temperatures are aren't that warm. Whereas if you go further west, there's usually that kind of that upper tropospheric trough that dips down near the Caribbean. So sometimes you get elevated shear in that region, but the water temperatures are plenty warm to support any nasty hurricane that you want. So it's a matter of basically getting that trough to lift out so the shear is low combined with the very, very warm water. So if you get, if you get a storm in there in the right environment with those excess upper ocean heat content, that can obviously lead to a very, very strong hurricane.
Yeah, cool. That makes sense. So it probably behooves us to really pay attention on the shorter term forecast, your 2 weeker down to the NHC scale as to whether we have a storm track coming across the Caribbean, to start looking at those other factors.
Yeah. I mean, really, and Bill Gray always stressed this too. I mean, the Atlantic, your sea surface temperatures do correlate, but a lot of the correlation is at least somewhat directly tied to the actual impacts on the shear, because the shear is really, really just, the shear is a really big factor in the Atlantic, because canonically the shear is marginal. So that's why your hurricane season is so peaked in the Atlantic in September, is when your shear is really low enough to really ramp up the storms. By October, the shear goes back up. So I always basically the things I look at are the shear, the moisture, and then the sea surface temperatures. But obviously there's more volatility in the shear and the moisture. Sea surface temperatures, if they're warm middle of August, unless you get a nasty hurricane that cools the waters off, you're probably going to be warm 1st of September as well. Yeah.
The question someone had posted here, I don't have an answer. Maybe you do. Why do you think the July sea level pressures were so much lower than normal across the tropics this year?
I think it's more just usually when the water temperatures are really warm, the pressures tend to be low just due to hydrostatics. Why the pressures were so low, there wasn't a lot of subseasonal variability. Sometimes you can get subseasonal variability that will lower the pressures and raise the pressures. We do have some subseasonal variability coming through now. We're going to have basically a suppressed convectively coupled Kelvin wave and kind of an MJO that's going to probably raise the pressures for the next week or so, and then it'll probably go back down as we go more towards mid to late August. But exactly why the pressures were so low, typically when you have really warm water, you tend to have low pressure, but then exactly why they were lower than some other years with even slightly warmer water, there's probably a little bit of subseasonal variability, and then there's probably just a little bit of noise that goes into that too.
Wow, that led right into the next question that I wrote down here was, what do you see in the coming month of August for where we'll sit in the MJO?
Yeah, so with the MJO right now, the MJO had generally been fairly weak. So there's the Madden-Julian oscillation is a way, basically equatorially propagating convection that goes around the globe about every 30 to 60 days. Sometimes it's strong, sometimes it's weak. So when it's weak, you don't necessarily get a lot of variability in the overall you don't necessarily get a lot of tropical, you wouldn't necessarily get a lot of tropical variability. So right now it seems like it's amplifying and is likely going to be going into phases that would tend to overall suppress hurricane activity in the Atlantic for the next 10 days to maybe as far as 2 weeks. But then after that, assuming the MJO continues to propagate, it would be leading into more favorable overall phases for Atlantic hurricane activity. So in addition to having overall hurricane conducive conditions kind of just on a seasonal timescale, we may also have subseasonal variability that would then be favoring hurricane activity as we move into to mid to late August. But the models, until the MJO maybe gets a bit stronger, the models don't necessarily have a great idea of exactly how it's going to propagate and how strong it's going to be. There is some disagreement with the various models as to exactly how that's going to propagate over the next several weeks.
Wow, this is awesome stuff, Phil. I really enjoyed this one. I think I better order a new set of running shoes. I'm going to need them this next 2 months. Tim, back to you.
Thanks, Bill. And let me ask you one more thing, Phil, because I know you look at statistics and history. And in South Texas, we've been hit once this year already. The Carolina Coast has been hit once this year already. Tell our viewers that doesn't mean they can stand down.
Yeah. So there's nothing about, so whether you've been hit by a hurricane this year or you haven't been hit, if you haven't been hit, it doesn't mean, oh, now we're due. And I want to make sure that people realize that just because, this is 2020 and all this other crazy stuff is going on in the world with COVID, it doesn't necessarily mean that the world's coming to an end and every single hurricane that forms this year is going to slam into the U.S. There's, even if we're forecasting a very active season, the theory may be such that most of those storms stay out to sea. So we really can't say, but yes, just because you've already experienced a hurricane doesn't reduce your odds. Likewise, even if you haven't experienced a hurricane, doesn't increase your odds. Each hurricane is basically independent of the one before it. So there's kind of like if you get a 100-year flood, doesn't mean you won't get another flood for 100 years. That's the same thing with hurricanes. Whether you get a landfall doesn't mean you won't get another one, and whether you haven't had one doesn't mean you're necessarily due to get one.
Great information, Phil. Thank you. You have successfully earned MASP 2.0. You have 1.0. We will send you 2.0 now. There you go.
Awesome. Thank you.
Just a little bit different, but every time we get a new one and you come on, you'll get one. So thank you for that. We appreciate that. Phil, thank you so much. Dr. Phil Klotzbach, Colorado State University. The seasonal forecast updated today, and 24 named storms. That's a lot. That is a lot of named storms. Thanks, Phil. We appreciate it.
Thank you.
Bill, thank you for all your input. We really appreciate that as well. Bill Reed, thank you for being part of this as always. I want to thank our sponsors once again, USAA, Plylocks, and the South Padre Island Convention and Visitors Bureau. We appreciate all you do to make this possible. A lot more great programs coming up in the weeks ahead. Let's go to Alex Garcia. An update on what we can expect. Alex.
Well, thank you there, Tim. This is what we've got set up. We've got a couple of really great panel discussions coming up next week. We have a panel discussion with members of the National Hurricane Center. That's Ken Graham, Jamie Rome, and Mike Brennan. We're going to be talking about the season and moving forward. After that, we've got another great panel coming up on hurricane messages, safety messaging. So 2 fantastic panels coming up here for the rest of August. We hope you enjoyed today's program, and don't forget, of course, our sponsors that are out there, USAA, South Padre Island Convention and Tourist Bureau, and Plylocks Hurricane Clips. Again, thanks for joining us, and join us again next week.